Welcome to the Blitz Edition of Prime Numbers. We are going to be reviewing everything you need to know about prime numbers really quick. We're going to learn how to do prime factorization and other types of factoring, and we're going to learn some division tricks that make life easy. We're going to talk about why the number 1 isn't prime or composite. And last thing we're going to learn about is what it means if numbers are relatively prime or not. So since it's a Blitz edition, it's not maybe the best idea to be learning about prime numbers for the very first time. This is more of a review. And it's going to be fast-paced, so feel free to pause the video and rewatch it. Now, the most important thing about a review is that you have to do some reflection about what you've learned. So at the end of the video, there are some questions that you should answer. They are not math questions, but for some math practice, you can just visit the link that's in the video description. So the reason that prime numbers are a very important topic is because factoring is a huge part of math. So factoring is when you break something apart, and prime numbers are just inherently a big deal, a big part of that. And so when you're dealing with square roots or rational expressions, all these things that come up later in math, you have to be familiar with how prime numbers work. So let's get started. Now, the difference between prime and composite has to do with the number of factors. And math definitions are extremely precise. So this one right here says that a prime number has exactly 2 factors. So a prime number is a number that has exactly 2 factors. And factors, again, are numbers that multiply together to make another number. So like number 14. 2 and 7 are a pair of factors of 14 because 2 times 7 is 14. The other would be 1 and 14. 1 and 14 make 14 also. So a composite number, though, a composite number has more than 2 factors. So a prime number, exactly 2 factors. Composite number, more than 2 factors. So that leaves us with 1. The number 1, it doesn't have 2 factors. It only has 1 factor, itself. And that means it doesn't have more than 2 factors. It's kind of an oddball. It doesn't fit with either group. All right. Now, for doing all this factorization, it's a good idea if you know what prime numbers are. So what we got here is a list of the first of 100 numbers, 1 through 100. And we're going to mark off of this list numbers that are not prime. So 1's not prime. 2 is, which means that anything 2 goes into is composite. Because like, say, for example, 4 here. 4 is, of course, 4 is 2 times 2, and it's also 1 times 4. That's 2 pairs. That's 4 factors in the number 4. To be prime, it has to have exactly 2. So anything that 2 goes into will have more than 2 factors, so we're going to take those off the list. We're going to do the same thing with 3. Everything 3 goes into, we're going to get rid of. Same with 5 and 7. Here is a picture of the prime numbers less than 100. Might be a good idea if you make a short, quick list to have for reference when you're learning how to do prime numbers until you get kind of an idea and you remember, oh yeah, 83 is prime. All right, onward and upward. How to factor. Now, what you're doing when you're being asked to factor is you're finding numbers that multiply together to make the number you started with. And this can get a little frustrating, especially if you have a big number. But let's start off with something not too bad like 33. In order for 33 to be prime, it would only have 2 factors exactly, like 1 and 33. The thing is, though, 33 also has 3 and 11 as factors. So it has more than 2 factors, which makes it composite. Now, what if we had an ugly number like 4,137? I'm going to show you some shortcuts. So it turns out 3 goes into 4,137. We don't need to know how many times, but since it does, that makes this composite. So let's look at some of these shortcuts. Now, you can tell if a number is divisible by 2 if it's even. Even numbers end in 0, 2, 4, 6, and 8. So all you got to do is look at the very last number. So you might have some giant number, 3, 7, 9, 4, 1, 0, 0, 4, 2, 7, 6. this last number. If that last number is even, 2 goes into it. If 2 goes into it, it's composite. That's how it works. Now, 3 is my favorite shortcut. The shortcut for 3s, all you do is you take all of the digits of the number you have and you add them together. And if 3 divides into that sum, then 3 goes into the original number. So let's take a look at the one we were having a minute ago, 4,137. 4 plus 1 is 5. 5 plus 3 is 8. 8 plus 7 is 15. 3 goes into 15, so 3 goes into 4,137. Let's take a look at 5s. If you have a number that ends in a 0 or it ends in a 5, then 5 goes into it, and, well, that would make it composite. So like you might have this number here, ends in 5, it's composite, has more than 2 factors. Done. Now there are also shortcuts for 7 and 11, but for what we're going to be doing, they're not really shortcuts. They're a little bit more difficult than just doing the simple division. Now let's talk about relatively prime numbers. 2 numbers are relatively prime if they do not share a single factor other than the number 1. 14 and 9. Neither of these are prime numbers, which is fine. They don't have to be prime. But relatively prime is talking about, do they share factors? The only factor they both have in common is a 1, which makes these relatively prime. A non-example would be 14 and 21. With 14 and 21, they share a 7. That makes them not relatively prime. All right, now, sometimes it gets confusing because a lot of the time, a step for doing some math will say, hey, factor the number. Sometimes instructions say factor completely or do the prime factorization. So I'd like to explain the difference between the 3. Now, when you're factoring, just factoring, it's highly contextual. It depends on what math you're doing. So sometimes 4 times 10 would be a perfectly, like exactly what you should do, whereas 2 times 20, which are also factors of 40, might not be so useful. And that might be a case like if you were doing the square root of 40. You'd want this, not this, because this would be a lot easier. But neither is wrong, it's just the context of the problem which makes it more useful. So factor completely though, that's different. If you're being asked to factor completely, then you need to write out all of the factors of the number. Now, word to the wise. When you're doing a complete factorization of a number, don't skip around. Don't say, oh well, 40. Oh yeah, that's 4 times 10. And then you're like, oh yeah, 5 times 8. And then you're like, oh yeah, the easy 1 times 40. You skipped stuff. You did not go in order. You didn't start with 1 and then see if 2 went in and 3, 4, 5, and so on. Now it turns out 3 doesn't go in, but if you skipped it, Murphy's Law would make this one of the factors. And so you would miss the problem. So, prime factorization. That's a little different than complete factorization because you're only being asked to write out the prime numbers. So like this number right here, 4, would not be in your answer because 4 is 2 times 2. And neither would any of these others. Those wouldn't be in your answer either. So with prime factorization, you're being asked for what's the list of prime numbers that multiplies together to make what you start with. And this would be correct here because, well, 2 times 2 is 4. 4 times 2 is 8. 8 times 5, 40. All right. Do a few examples. Find the prime factors of 48. Now, a lot of times people use a factor tree, which is absolutely fine. Thing is, though, when you're done, you need to write out your list because more than likely, you're going to be doing some math with these factors beyond just the factorization. So, factor tree would be like, oh, well, 2 times 24 is 48. And then, well, 24, that's not prime. 2 goes into it 12 times. Oh, and 12's not prime either. 2 goes into 12 6 times, and 6 is 2 times 3. So this right here, these are your prime factors. And you need to make them into a list. So you could do 2 times 2 like this, or 2 to the 4th times 3. Doesn't really matter either way, but when they're asking for prime factors, you're only writing the prime numbers that multiply together to make the number you're starting with. All right. Now, that's different than factoring completely. When you're factoring completely, 48, what you're doing is you're finding all the numbers that multiply together, all the pairs that multiply together to make 48. Whereas with prime factorization, you're not really looking for pairs of numbers. You're looking for a list of the prime numbers that multiply together to make 48. 1 and 48. Now 2 goes in 24 times. 3 happens to go in because 4 plus 8 is 12, so 16 times. Now 4 goes in 12 times. 5 does not go in. But if I skipped checking 5, I'd be in big trouble. It's just Murphy's Law. 5 would end up being a factor. 6 goes in 8 times. 7, no. Next number that goes in is 8. Now, because I did not skip any numbers, and you see how these are just turned around? That means this right here is my complete list. So, a couple things you need to think about right here. What did you already know? What did you relearn that was really easy for you to relearn? Maybe even seemed obvious to you after you saw the video. And what's still confusing? Thing that's still confusing, you probably should do a little more research. Now, last thing, if you found this video to be helpful, you could help me out to make more of them. All you gotta do is click like, subscribe, share it with your friends, and visit my website, thebeardedmathman.com. Last thing, for some practice problems, again, just visit or just read the description, and there's a link there to some practice problems you can try. Thanks for watching.